Trigonometry is used a lot in surveying. You'll probably use it a lot if you're going into solar to determine angles for your solar panels. So angles of elevation. The first example they give here on the bottom of 168 is, in order to find the height of a building, an observer who is 6 feet tall measures the angle of elevation from his head to the top of the building. Okay, so we need to draw a triangle here. Here's my observer. So the angle from the top of his head to the top of the building, that's this angle right here, is a 32-degree angle. He is standing 200 feet from the building. So here's my building over here. Okay, so this length is 200 feet. It also tells me my observer is 6 feet tall, which is important. It says, how tall is the building? So this is my A, and here's my B. This is the little side A, the little side B, and C, hypotenuse. They're asking me to find how tall the building is. So that's my little side A. So what do I know that's going to help me to find little side A? I have angle A and side B. Which of the ratios do I need to choose? Do I have the hypotenuse? Okay, then I know I can't use cosine. Very good. Tangent. So the tangent for angle A, so tangent, opposite over adjacent. So opposite angle A, side A, and then adjacent, side B. So then fill in what we know. Tangent for 32 degrees equals side A over 200 feet. So to get the little a alone, A equals 200 times the tangent of 32. 32 tangent times 200 equals 124.97. You can round that up, 125. Is that the height of our building? No, that's the height of this part right here from, what about this little piece? Okay, that was our observer height. And he was how tall? 6 feet. So we need to add side A, add 6 feet to that. So how tall is this building? 131 feet. Okay. So the building is 131 feet. So top of page 169, a hiker standing on the top of a 150-foot cliff. So this is just my preference. I always like to draw the little pictures. So here's our cliff. We've got my little hiker up here. Sights a boat at an angle of depression 24 degrees. Okay, so an angle of depression going down. There's 24 degrees. Here's my little boat. What else did they tell me? Okay, my cliff is 150 feet. Did they tell me anything else? The hiker's eye level is 5.6 feet. Okay, 5.6. So what's this total side length going to equal? 155.6 feet. All right, now I've got my triangle drawn. What are they asking me to find? How far is the boat from the base of the cliff? That's this distance over here. Let's call this A and A. And our boat's B. Well, this is our B side. which equation do I need to use to find this side A? I'm given an angle and a side. Okay, tangent again. Tangent of angle A is opposite over adjacent. Fill in what we know. This is a 24-degree angle. I'm looking for the little a side, and I know the B side is 155.6 feet. Okay, then get A alone. A equals 155.6 times the tangent of 24 degrees. Grab your calculator, 24 tangent times 155.6 equals 69.28. Does everybody get 69.28? Okay, so let's figure out how far it is from the hiker down to the boat. So that's our C side, right? Our hypotenuse side. So using the information given, angle A and side B, which equation should I use? Cosine. Okay, so the cosine for angle A equals adjacent over hypotenuse. So the cosine of 24 degrees equals 155.6 over the hypotenuse length. And the hypotenuse equal to 155.6 times cosine of 24 degrees. 24 cosine times 155.6 equals 142.15. That's the distance from the hiker to the boat. Is that right? Okay, how do we know that's not right? Okay, our hypotenuse has to be the longest length of the triangle. Which one is longer right now? 155.6 is longer than 142. So we know we made a mistake somewhere. So let's go back and see. What can we see here? So did we do that right? 155.6 divided by the cosine of 24. So 155.6 divided by 24 cosine equals 170.325. Okay, there we go. So our hypotenuse length is 170.33. Now is that our longest length? Okay. 170.33. Keep going right there. It says a local photographer gets a tip that a boat cruising down the river is something he wants to take a picture of. So he sets up his camera at the top of a bridge. So let's make this our bridge right here. Our bridge is 22 feet high and 60 feet away from a bend in the river. So here's 60 feet. He's hoping that the boat is going to come around the river. At what angle of depression should he aim his camera? So the camera's up here. So which angle? We need to solve for this one right here. Okay, I'm given two side lengths. Which one's in relation to my angle? Opposite and adjacent. All right, so tangent for angle A, opposite, that's my little a side, 60 feet over adjacent, it's my little b side, 22 feet. Opposite over adjacent. 60 divided by 22. So the tangent for angle A, 2.727 forever. So either use your book, table of trigonometric functions on 179, or second function, tangent on the calculator. Angle A equals 69.86 degree angle. So about 70-degree angle is how he needs to aim his camera. Let's figure out how far away from his boat the camera actually is. So that's our side C. We'll call this a 70-degree angle. How should I solve for side C? Well, I know what angle B is, right? 70 plus what is 90? 20. Okay, so now I have both angles, two side lengths. Right, there's a multitude of ways we can do that. I can do a squared plus b squared equals c squared. I can use either angle A or angle B and do sine or cosine on either of those. So 5 different ways I can figure it all out. Everybody choose one and then we'll compare answers. Eric, tell us how you're doing it. Okay, sine of angle A. So sine equals opposite over hypotenuse. So opposite, 60 feet over the hypotenuse. So angle A is a 70-degree angle. And I need to get C alone. It's a C. C equals 60 over the sine of 70 degrees. Okay? 60 divided by 70 sine equals 63.85. Is that my longest length? Remember, the hypotenuse always has to be the longest. Okay, it is longer. How else did we do this problem? Okay, let's use side B. If I use the angle B to find my hypotenuse length, which formula should I use? Okay, let's go cosine of angle B. The cosine equals adjacent over hypotenuse. All right, cosine of angle B. So adjacent over hypotenuse. Which side is adjacent to angle B? Is our 60. So 60 feet over the hypotenuse. So angle B is a 20-degree angle. Cosine 20 degrees, 60 over the hypotenuse. So again, those swap spots. C is equal to 60 over cosine of 20 degrees. 20 cosine 63.85. So there's our hypotenuse length again. Last one. Try this 1-7 right there on 169. It says Marie hopes to photograph the rising sun as it peeks over the top of a 20-foot tall house across the street, 120 feet from where she's sitting on the ground. Let's draw our triangle, try and figure out what they gave us here. We're going to put Marie right here. She's sitting on the ground. "20-foot tall house across the street." So that's this measurement right here, 20 feet. She is sitting 120 feet away. So there's what they gave us. At what angle of elevation should she aim the camera? So that's our angle right here. So if we call this C, we'll call Marie A, B. So we have two side lengths, and they're asking us to find angle A. They didn't give me the hypotenuse, so which one do I have to use? Okay, tangent. If I do the tangent of angle A, it equals tangent opposite over adjacent. So opposite of angle A, little a, and adjacent, little b. So the tangent for angle A is 20 over 120. So our tangent for angle A equals 0.1666667. Second function, tangent A equals 9.46. That's a pretty small angle, 9.46. So what would our angle be? Where would the sun be in relation to the building? What would the angle there be? So A plus B has to equal 90. 90.946, 80.54. Okay, so angle B is 80.54 degrees. What do I not know yet? Okay, the distance from her camera to the top of the building. So let's find our hypotenuse length here. Everybody pick a way to do it, and then we'll compare. Eddie, you walk us through the way as you do it. Okay. Sine for angle A. What's our formula for sine? Sine equals opposite over hypotenuse. So opposite of angle A is the little a side over the hypotenuse. So I know my angle A is 9.46. So if I do a sine of 9.46 equals 20 over my hypotenuse length. Swap those out. My hypotenuse equals 20 over the sine of 9.46. Grab your calculator. 20 divided by 9.46 sine equals, my hypotenuse length is 161.68. Is that my longest length? Yeah, barely. 120. Let's verify that using a squared plus b squared equals c squared. So A is 20, B is 120. And I want to verify my C. 20 squared plus 120 squared equals 14,800. And then square root that. C equals 121.66. So pretty close in value right there. Okay, that was the end of this chapter. You're going to want to go on and do the homework. We aren't going to go any farther in the book. The next section on trigonometry, you will probably want to go through that at some point. It talks about the different quadrants and how you would decide which to use. It has the table of trigonometric functions in there. It talks a little bit about radians to degrees and the conversion ratio there. You will use some of that as you get on into energy essentials and solar in particular. But for today, that's as far as we're going to go in trigonometry. Go through and do the homework, and we'll review those together tomorrow, and we'll test. Does anyone have any questions that we want to review? Okay. Then I will see you tomorrow, and we'll review the homework.